Integration by parts. In theory, it's simple, but in practice, it can be hard to understand. When is it applied, how is it applied, and how does it work? Prepare for knowledge. Integration by parts is used when you want to integrate an equation with two separate functions multiplied by one another. It works best when one function is able to be integrated simply, like a sine function or e to the x, since these both integrate into similar or equivalent functions. One classic example of a good usage of integration by parts is x times sine of x. We use this later for demonstration. The formula itself is simple-ish. The integral of u derivative v is equal to uv minus the integral of v derivative u. For this video, I'll be using u and v prime instead, since it's easier to say. It may seem a little complex on first glance, but trust me, it gets easier. Just remember that v prime is the function that can be integrated simply, and u is the function that's multiplied by it. With our x times sine example, u would be x and v prime would be sine of x. Now if we use the formula, we get x times the integral of sine of x minus the integral of sine of x times the derivative of x. Since the integral of sine of x is negative cosine of x and the derivative of x is 1, we can simplify this to negative x times the cosine of x minus the integral of negative cosine of x. Finally, with the integral of negative cosine of x being negative sine of x, we're left with negative x cosine of x plus sine of x. Now we've eliminated all integrals, and the integration is complete. So that's pretty cool, but how does it work? Where did this wacky rule come from? Interestingly, it derives from the multiplication rule, where the derivative of u times v is equal to u times v prime plus u prime times v. See how there's one prime in each addend? Let's take this backwards. The integral of u times v prime plus u prime times v is equal to u times v. Now we separate the two addends into their own integrals, and we're starting to see something familiar. After subtracting the u prime times v to the other side, we're left with our original formula. It's sort of simple, actually. The integration by parts formula is good for eliminating a second function from an integral. For instance, if you have x multiplied by another function, it's difficult to find what the integral of that is. However, if you can remove the x by taking the derivative, as is done with u in the formula, you only have to worry about integrating one function, as long as you remember the u times v minus at the beginning. Of course, if you have an x to an integer power greater than 1, you'll have to use the formula multiple times. Or do you? Here's where we enter tabular method. If you understand how to use the integration by parts formula, you can integrate with it as many times as you need to reach a proper answer. Say, with u of x cubed, you'd need to integrate 3 times, which can be a lot of work. To speed this up, we can use what's called the tabular method, which, as the name suggests, involves the use of a table. Try this. Draw a table with 2 columns, putting your u at the top of the left column and v prime at the top of the right. For now, let's say u is x cubed and v prime is sine of x. Let's add a new row to our table. In the left column, the next row is filled by taking the derivative of the function above. In our case, the derivative of x cubed is 3 times x squared. In the right column, the next row is found by taking the integral of the function above. In this case, the integral of sine of x is negative cosine of x. Now, keep adding rows, deriving and integrating, until the value in your left column is 0. Your table is filled. What does this have to do with integration by parts, you ask? Patience, Padawan, all in good time. Key thing to remember with tabular method is the alternating signs. In the first row, multiply the left function by 1. In the second row, multiply it by negative 1. Keep doing this for each row, alternating signs. Now we're ready to find the final formula. This process is typically illustrated by drawing diagonal arrows from a function on the left to a function to the right that's down 1 row. We'll start with the first row, drawing an arrow from the left function, x cubed, to the right function 1 row down, negative cosine of x. Multiply these together and they are the first term of your formula. Repeat this for the second row and the third until you end with the row before last, drawing an arrow to the last row on the right. Remember the alternating signs when writing down your terms. When you're finished, you have your final formula, which is the integral of your initial functions. This may seem a long process, but when you do it quickly, it saves a lot of time. Draw a table, derive and integrate your functions multiple times until you have a zero, and alternate the signs. Draw some arrows, multiply functions by one another, and add it all up to get your final formula. How does it work? Don't worry about it. It's complicated. Just make the table and get on with your life. The end. If you have any questions, please talk to your teacher or call or email them, depending on what point in time you exist. Goodbye.